ठीक है, सो ग्रेविटेशनल फील्ड हम देख लेते हैं कि व्हाट इज दिस, राइट? सो अगेन, as we have discussed before, कि we have mother earth, right? This is our mother earth over here, this is the center of earth, oh, ठीक है. So under this region we have gravity, right? It is pulling everything in this region, ठीक है. So this is basically gravity, right? And this entire thing, this entire region is called what? Under which it can the earth can apply gravitational force, that is called gravitational field, right? Okay, so the force of gravity acts through the space and can cause an object, but not in contact with the earth to fall to the ground. As I told you example before also, the last class, कि even if you are at space, but you are near to the earth, ठीक है, your earth will be pulling you towards yourself. ठीक है, so gravity is a force that acts without any contact, right? So even if you are far outside the Earth's boundary, still there will be a force of gravity that will try to attract you, right? But it will be pretty small as compared to on surface, right? अगर 10 है भी तो वहां पे it could be around 3 4, right? ठीक है, so we try to explain its existence by saying that the Earth is surrounded by a gravitational field which exerts a force on any object in the field, right? So imagine कि this is the field. Even if you are on the, let's say, in an aeroplane over here, let's say you are over here, right? In an airplane, right? So यहाँ पे भी there would be a force of gravity acting. Still, but you are not in contact with the earth. You are just sitting in a plane, which is again flying in the air, which is also not having any contact with the ground. Still, it is going to attract you, right? Gravitational field strength is defined as the force acting per unit mass. We will describe this ये कैसे हो रहा है, ठीक है? So, is gravitational field strength is a vector quantity or a scalar quantity?
Vector.
Because as I draw the diagram over here, you can see from here, okay, it has all arrows shown over here, right? So gravitational field strength has a point, right? It has a direction, okay, where is the gravity attracting everything towards the center of the earth, right? अच्छा, इन योर एस्ट्रोनॉमी एंड कॉस्मोलॉजी चैप्टर विल डिस्कस के अगर ग्रेविटी बहुत ज्यादा स्ट्रांग हो जाए, राइट? जब ऐसा सिनेरियो आते हैं कि मैंने स्टार बेसिकली कूल्स ऑफ ना, लेट्स से सन की हमारी लाइफ इज मिलियन ऑफ ईयर्स, राइट? So let's say there is a time at which the sun's fuel, that is helium, right, that is fusing. तो वहाँ सन पे we are causing fusion. वहाँ पे फ्यूजन हो रहा है, उससे बेसिकली हाइड्रोजन एटम आर कंबाइनिंग टुगेदर, ठीक है? We have hydrogen atom combining together to form basically an helium atom, right? 4 2, ठीक है? So so it deuterium and tritium, deuterium and tritium, yeah. तो यहाँ पे हाइड्रोजन के आइसोटोप्स मिलके ना हीलियम एटम बना रहे हैं, ठीक है? सो फ्यूजन हो रहा है यहाँ पे. So this basically hydrogen is a fuel, right? Hydrogen atoms are again not in abundance; they are in a lack of amount. So yeah, they are not going to last forever, right? So sun की भी there is a lifetime, okay, but it is million of years, so don't worry. So this is the reason कि अच्छा अब when a star like sun cools off, ठीक है? So there is some property, there is some rule. If the gravity is pretty strong, if it gets pretty strong, it can basically crush the entire sun into a single point, ठीक है? And after that it becomes a black hole, ठीक है, or a wormhole. ठीक है, you will study this in your chapter, in your cosmology chapter, कि how does this happen, ठीक है? And what is the life of a star, how does a star is born, ठीक है? And how is a black hole born, ठीक है? And when does it die? Even black holes die off, ठीक है? Everything dies off, ठीक है? That is composed of matter. Everything has an ending point, ठीक है? So its direction is same as a gravitational force. That is why it is a vector quantity. It has direction and magnitude and SI unit, right? ठीक है, so this is basically this is representing G जो हम लिखते हैं फॉर्मूले के अंदर. This is your gravitational field strength in your formula weight. Gravitational field strength, basically the acceleration of gravity, right? So let's derive why do we have these two units over here, right? So we will be using 9.8 for the course just to stay consistent, right? So we have two units shown over here, right? Newton per kg and meter per second square. So why is it the case? Okay, so let's analyze it. So let's analyze why is it Newton per kilogram. So we have the formula weight that is equal weight that says weight is equals to mass times gravity, right? If I try to make gravitational field strength, इसमें basically what is W? W is the weight.
जी
Okay, ठीक
Yes.
है. So let's begin. So I was just saying the terms के weight is basically W is weight over here. M is equivalent to the mass of an object, right? And the G is your gravitational field strength, right? It is your gravitational field strength. So we are going to derive the SI unit for this particular quantity, right? G. Okay, so let me insert a blank slide. So let's manipulate the formula, right? So we have weight equals to mg. Let's make g subject, right? So we're going to get weight upon mass, right? If you recall, what is the SI unit of weight, which we have seen? It is Newton, right? And what is the SI unit of mass? It's kilogram. Therefore, we have one of the possibility of SI units of gravitational field strength as it is Newton per kg. Does that make sense?
Yes, sir.
Okay. सबको समझ आया? Give me a thumbs up जल्दी जल्दी. Okay, Ryan को clear है, मशाल को clear है, हमजा को clear है already. And what about Vardha? Yeah, it's clear. That's good. Okay. So now let's see why is it meter per second square, right? Why is it meter per second square? Why is it meter per second square? So again, imagine what was the point from where we derived the weight equals to mg formula, right? We derived the formula from certain thing, right? What was that? What was the rule which we
F equals to ma.
yeah, we use this formula, which was a Newton's second law, that is F equals to m, right? So इसके अंदर what are we comparing, right? We compared कि A is same as the G right over here, which is acceleration. Let me just fix my T. It's not good. Acceleration, right? So imagine why is it same? So as I told you before, अभी भी बता देते हैं आपको हम. Okay, imagine you are in a hot air balloon, right? And you love doing bungee jumping, right? These are the supporting pillars, and you have the balloon, right? And you do bungee jumping, you have this particular rope, and you are basically feeling the gravitational field stream, right? So what happens? You are free falling, right? It is free falling. You are not. You're basically completely falling under gravity only. There is no external forcing. There is no external force जो आपको push कर रही है या pull कर रही है. Right? It's completely if you are accelerating freely in the atmosphere, so your acceleration value will be equals to gravitational field strength, right? So imagine what is the SI unit of acceleration? It is meters per second square, right? So since value of gravity is constant, that is 9.8 meter per second square. So you can imagine K, you are falling under an acceleration, constant acceleration of value of 9.8 meter per second square. Okay, so that is stating K, if you have a gravitational field strength acting on your body and you are doing in free fall motion, so acceleration of your body will be 9.8 meter per second square. We can also derive this. We can also derive this from this formula. Okay, acceleration is basically equivalent to G. Okay. And what is the SI unit of acceleration? That is again meter per second square. And therefore, we can just use this representation also to represent your gravitational field strength as such. Okay. Does that make sense?
Yes, sir.
Okay. Okay. If you have a question, please you can raise the hand and ask. And in the next slide, there is some analysis of the situation which we discussed. Okay, we have two ways regarding G. Okay, when considering objects falling freely, we can think of it an acceleration of 9.8 meter per second square. That has been discussed in the last slide. When an object is of known mass is at rest and we wish to know the force of gravity acting on it, So we can think G as the Earth's gravitational field strength of 9.8. ठीक है, imagine अगर आपने, let's say you have a box over here, right? And it is basically at rest. So what is the gravitational field strength that is causing it to basically be still at this particular position? Okay, you can define this as, it is gravitational field strength is basically applying near 9.8 Newton per kg to basically keep this body at this position at a particular instant of time. Okay. So the gravitational field strength is equivalent to acceleration of free fall, which we have seen. So the weight of an object is directly proportional to its mass, जो हमने अभी देखा है, ठीक है? We explain कि why G is same for all objects. तो ये पॉइंट हम देखते हैं भी, ये क्या बोलना चाह रहा है. इट्स बेसिकली सेइंग द, इट्स स्टेटिंग द फॉलोइंग थिंग. इफ आई ड्रॉ द ग्राफ, ठीक है, दिस इज मास ओवर हियर, दिस इज द वेट. एंड इफ आई ड्रॉ, इफ आई एम जस्ट सेइंग दिस इज द फॉर्मूला, राइट? वेट इक्वल्स टू एम जी. इफ आई, अच्छा हमारे पास क्या है, हमारे पास जी इज कांस्टेंट, राइट? अर्थ की कांस्टेंट होती है, दैट इज 9.8 मीटर पर सेकंड स्क्वायर. नाउ आई वांट टू क्रिएट रिलेशन बिटवीन वेट एंड मास, एंड वी केम टू कंक्लूजन कि वेट इज directly proportional to mass, right? Because keeping that in mind, कि g is constant. So we can see that there would be this particular relation, right? It's a straight line. And if you recall in basic mathematics class, the slope of a straight line is what? Is something.
Acceleration.
Is
Acceleration.
नहीं, स्लोप ऑफ अ स्ट्रेट लाइन, अगर आपके पास कोई स्ट्रेट लाइन हो, उसका आप स्लोप निकालें यूजिंग एनी टू पॉइंट्स, लेट्स से पॉइंट ए पॉइंट बी, वो विल बी कांस्टेंट और वेरिंग. लेट्स से
Constant.
Constant.
yeah, if you have multiple points, if you take point A, C, if you take point C, B, if you take point A, B, you get the same value of M. Okay, that is constant. So if you find the slope of this particular graph using any two points, ठीक है, लेट्स से आपने ये चेंज इन वाई ले लिया और आपने ये पूरा चेंज इन वाई ले लिया, ठीक है, और आपने if you use this change in x, if you using change in x, so you will end up with the same value, that is going to be change in weight upon change in mass, that is going to be constant, right? That states the reason, that is the relation between weight and mass, right? Gravity on a single planet is going to be constant. So weight over mass ratio is going to be constant throughout any single planet, right? That is why gravity is constant. Okay, thus we can say gravity is constant in a single particular planet, right?
सर ग्रेविटी से रिलेटेड ग्राफ्स हमेशा कांस्टेंट होंगे.
नहीं, मतलब वेट, अगर आप ये रिलेशन देखें ना, ये रिलेशन देखें हमने कैसा बनाया. वी यूज दिस इक्वेशन, राइट? सिंस वी वांट टू से ना कि हमारे पास व्हाट इज द रिलेशन कमिंग आउट कि वेट इज डायरेक्टली प्रोपोर्शनल टू मास. हमने इसको प्लॉट करा, राइट? Here, and this relation is saying कि it's a straight line, and then if I try to find the slope of the straight line, it comes out to be constant, right? Because it's the straight line. So gravity constant है, we can support this by using this experiment, right? So you can change mass, you can use different masses. Let's say आपके पास ब्लॉक्स हैं, right? आपके पास 1 kg का ब्लॉक है, आपके पास 2 kg का ब्लॉक है. आप उसकी ना वेट को ना वे करें using न्यूटन मीटर. Then you can plot this graph, right? You can plot this graph and it will come out to be exactly this particular trend. So you can say कि हमारे पास जो वैल्यू आ रही है ग्रेविटी की ऑन अर्थ would be pretty closely to 9.8 मीटर पर सेकंड. ठीक है, क्योंकि वेरीफाई दिस एक्सपेरिमेंटली टू. दिस कैन बी योर होमवर्क इफ यू वांट. इफ यू हैव अ लेट्स से वेइंग मशीन, कैन यूज डिफरेंट ऑब्जेक्ट डिफरेंट मासेस, तो आप उसको प्लॉट करें, चेक करें क्या हो रहा है. डज दैट मेक सेंस? यस और,
यस.
ठीक है, या. सो अच्छा, वी assumed, we discussed, we confirmed कि mass of an object is always constant, but the weight varies, right? Because it depends upon the value of gravity. ठीक है, on the moon it is 1.6 meter per second square. So the mass of 1 kg has a weight of 1.6 Newton. ठीक है. So now what is it saying is as follows. Let me just insert a blank slide. ठीक है. So it is stating the following, right? Imagine कि if we are talking about on Earth, right? This is on Earth, and this section is on basically on moon. right? Let's imagine if Hamza goes to the moon, right? Hamza ki let's say mass is around 55 kg. Okay. Mass would be same, right? On every part of the universe. So the mass भी यहाँ पे same रहेगी. I know the value of gravity on Earth, that is 9.8 meter per second square. I know the value of gravity, sorry, the gravitational field strength of the moon also, that is 1.6 meter per second square, right? I wish to find the weight of Hamza on Earth, right? कितना है? Similarly, I want to find weight of Hamza on moon. ठीक है? कितना आएगा? So I can just apply the formula. I know what is the formula of weight and mass, that is mg, right? So let's apply the formulas. So weight of Hamza on Earth is going to be 55 times 9.8. And similarly, weight of Hamza on moon will be 55 times 1.6 meter per second square. The weight of Hamza on Earth is coming out to be these many newtons. The weight of Hamza is coming out to be these many newtons on the moon. Right. So let's do this. So 55 times 9.8 is coming out to be 539 newtons. And the weight of the moon is coming out to be just 88 newtons. Imagine if you want to lose weight, right? Simply go to the moon, right? So imagine there's a huge difference. Like, there's a huge difference. अच्छा कुछ इश्यूज भी होते हैं राइट इफ यू गो टू अ प्लेस जहाँ पे ग्रेविटी की फोर्स बहुत वीक है सो आपके ऑर्गन्स आपकी बॉडी बिकम्स अनस्टेबल राइट बिकॉज योर हार्ट योर लंग्स योर किडनीज एवरीथिंग इनसाइड योर बॉडी इज डिजाइन टू बी बेसिकली at a particular gravity value of 9.8, right? If you go to a moon of gravity 1.6 meter per second square, your inside body basically organs start to expand, right? Because उन पर कम force लग रही है, right? What is also gravity? Gravity is Newton per kg, right? It's force per kilogram also. So your organs start to expand. That is why we have special designed astro basically space suits, which counteracts this particular effect, right? So this is just the end of the chapter. I hope it makes sense. So any questions till now? Hello.
सर ऑप्शंस एक्सपैंड कैसे होता है मतलब समझ नहीं आ रहा
हाँ तो imagine कि this is your heart, right? And this is your heart, right? In on Earth, right? Let's imagine this is on Earth. And उस पे जो gravity force लग रही है, ठीक है? That is 9.8 Newton per kg, right? If you go to the moon now, what happens? The same heart of your body, right? Experiences now a decreased gravitational force of 1.6 Newton per kg. तो एयर प्रेशर बेसिकली डिफरेंस से हमारे पास ऑर्गन्स विल स्टार्ट टू एक्सपैंड और दे आर डिजाइन टू बेसिकली एक्सपीरियंस दिस मच फोर्स राइट बट सिंस अब आउटसाइड फोर्स जो बेसिकली इसको दैट इज कीपिंग इट डाउन दैट इज फोर्सिंग इट डाउन टू स्टे एट दिस पर्टिकुलर पोजीशन दिस हैज डिक्रीज बाय वे ह्यूज अमाउंट so the organs also start to expand right there is also a movie on this particular topic so there was a first child that was born on Mars. So then he came onto Earth back to his parents, right? So his body starts to act abnormally because Mars gravity is around 6.4, right? Earth base 9.8. So जब increase भी होती है तो भी issue होता है